Okay, for this problem, x has a binomial distribution with parameters n and p. We're going to let capital P be equal to x divided by n. We'll figure out the expected value of x, or expected value of p, and the standard deviation for p. To do this, we remember that the expected value of x is equal to n times p, whereas the standard deviation of x is equal to the square root of n times p times 1 minus p. Therefore, the expected value of capital P will be equal to the expected value of 1 over n times x. That's what capital P is, 1 over n times x. So 1 over n comes outside the expectation. So 1 over n times p, which works out to be p. Next, the standard deviation of p is equal to the standard deviation of 1 over n times x, which is equal to 1 over n times the standard deviation of x. So that's the square root of n times p times 1 minus p all over n. And we can simplify this. We have a square root of n over n, so I can rewrite that as p times 1 minus p over n, where the n is inside the square root like that. If you've taken applied stats, you will recognize this. This is the standard error for the proportion of standard error for a proportion when you have a problem involving confidence interval or else a hypothesis test. But if you haven't had applied stats, don't worry about it, but this is something that comes up, one of the formulas that should be memorized in Math 3680, especially for involving hypothesis testing problems involving a proportion.